the robot isn't particularly intelligent, it's just trying to go to a point. But it doesn't avoid anything, and it doesn't know when it's tipped up or anything like that, it still keeps going. So by the use of sensors we can increase the effective intelligence of the robot. Something, you might have used this already, and that's great, but we have an ultrasonic distance sensor on the front of the robot, and the code is just, well, it's one command, read ultrasonic. And then I equals read ultrasonic, obviously I is a variable, so you define I. And then you can use serial free print, and then you can see what the distance is. So have a go with that. We also have a turret on it, so that will turn the ultrasonic sensor around. Now this turret is a very, very small servo motor. It's not a very good servo motor. It does break quite easily, okay? If it makes some weird whirring sound, it has actually broken. But you don't need the turret for what we're going to do, necessarily, but you can use a turret. And just so you know, turret, and then you put in an angle, and that's 0 for straight ahead. It doesn't go to plus minus 90 quite, I think it's plus minus 80 degrees. So minus 80 and positive 80, and you can move it around anywhere around there. Could you make the robot do something if there's an object in front of it? For example, stop and say, move out of the way, or turn left or turn right. I mean, have a go. Something you could do is stop the robot. An example code, if sensor is smaller than 20 centimeters, then stop. That's pseudo code, you know how to do the real code for that. Now something else I would like you to have a go at, which is really cool, this is also using control theory again. Remember when we were speaking about bearing? Well, this is very similar. Could you get the robot to follow a wall? So we've got wall space outside here, we've got wall space in the corridor or just outside. Find a bit of wall and see if you can program the robot to be at a distance of 50 centimeters away from the wall. Now you'll have to have the ultrasonic sensor turned to the right, so you might do turret minus 80, or if your turret's not working, you can unplug the wire of the turret and just manually, very slowly, without breaking the gears, just turn it to the right. The kind of code to follow a wall would be steering. So you would say, if it's 50, then steer forwards. If it's larger than 50, then steer slightly to the right, and if it's smaller than 50, then steer to the left. But rather than having 3 if statements, you could do it very nicely. You could say, steer angle is equal to 50 minus ultrasonic distance. Okay, and you will get a number, and the number will either be positive or negative, and you can put that into your steer command. So it will steer proportionally based on how far or close to the wall it is. If it's really far, it will steer quite sharply. If it's only moved a few centimetres away, it will steer quite gradually. You see? So try it with a steer command, and that is using control theory, just as we spoke about before. So steer, and it'll be 50, which is our desired, minus the actual value, which is what the ultrasonic value sees, and see if you can get the steer to work. You might have to change those, swap them around to make it positive and negative. Have a bit of a play with it. You might need to make it more or less severe. Remember we spoke about having a ×2 in there, or having a ×0.5 in there even, just to make it a bit more sluggish or a bit more jittery.